Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking new lesson in static. What is the title? Moment of the force about a point in 3 dimensions. What do you mean 3 dimensions? X, Y, Z, I, J, K. The last lesson we studied the moment in 2 dimensions. What is the moment of 2 dimensions about a point? Equals, yes, R vector cross F vector. In 3 dimensions is the same 2 dimensions. By using 3 dimensions, X, Y, Z, I, J, K, the moment is changed. Dear student, look at the lesson of moment in 3 dimensions. As the first, dear student, now we are translate 2 important rules in statics. Addition and subtract of 2 vectors geometrically. Look at, dear student, if we have AB vector plus BC vector equals what? AC vector. Sum of 2 vectors, AB vector plus BC vector equals AC vector. Look at, dear student, when we add AB vector plus AC vector equals AD vector. In a parallelogram ABCD, we have AB vector plus AC vector equals twice half AD vector, all equals AD vector. Number 3, if we have AD is a median, D is midpoint of BC. When we add AB vector plus AC vector equal twice AD vector. Look again, dear student, pay attention. We have 2 vectors, AB vectors plus AC vectors equal twice the median. If D midpoint of VC, then when we add AB vector plus AC vector, twice the median of triangle ABC. Number 4, when subtract 2 vectors with the same starting point as AB vector minus AC vector equals CB vector. Look again, dear student, subtract AC vector from AB vector. AB vector minus AC vector, 2 vectors with the same starting point and different direction equals CB vectors. The result of the 2 forces meeting at one point. Dear student, if we have 2 forces as F1, F2 meeting at a point, what is the result of these 2 forces is R. The result is R, angle between them is alpha. When we find the resultant of the 2 forces F1 and F2 included between them angle alpha, this rule is very important. R, or resultant of the 2 forces, equals square root F1 squared plus F2 squared plus 2F1 F2 cosine alpha. What's the direction? Tan theta F2 sine alpha over F1 plus F2 cosine alpha. Remember, dear student, we translate into special cases. The first special case is if 2 forces have the same direction, what is the measure of alpha equals 0? If we have 2 forces in the same direction, what do you mean? Angle between them equals 0. What you deduce, dear student? What is R equals F1 plus F2? Then when we find resultant of the 2 forces included between them angle alpha equals 0 or in the same direction, then the resultant equals sum of the 2 forces. And the direction of the resultant is the same direction of the 2 forces. Remember, dear student, if we have 2 forces in same direction, then the resultant equals sum of the 2 forces. What is the direction? The direction is the same of the 2 forces. Let F1, F2 are in the opposite direction. What do you mean? Angle between them equals 180. What is the result? The resultant in this case equal absolute F1 minus F2. And direction of resultant is the same direction of the greatest force in magnitude. Remember, dear student, if we have two forces in the opposite direction, the resultant of these two forces is absolute value F1 minus F2, and the direction of the R is the direction of the greatest force. If F1 more than F2, then direction of resultant is same of F1. If two forces are perpendicular, or F1 perpendicular F2, what you deduce? Yes, the resultant is of two forces square root F1 square plus F2 square. Remember, dear student, we have two forces are perpendicular. If you use the first or general rule, R equals square root F1 square plus F2 square plus 2F1 F2 cosine alpha, then cosine alpha in this case equal 90. Cosine 90 equals 0. Then the rule becomes the resultant between two forces equals square root F1 square plus F2 square. And the direction is tan theta F2 over F1. Remember, theta angle is angle between R and F1. Remember, dear student, if we have two forces are perpendicular, then when we find the resultant of the two forces, we use R equals square root F1 square plus F2 square. This is magnitude of the resultant, but direction we use tan theta equals F2 over F1. After that, we find theta equal shift tan. Answer, we find angle of measure theta or measure angle between F1 and R. Number 4, in special case, if two forces are equal and each one is equal F. What is the resultant? R equal 2F cosine alpha over 2. When, say, two forces act at a body, each one is 5 Newton, then resultant in this case equals 2F cosine alpha over 2, and alpha over 2, what is the alpha? Yes, angle between F1 and F2. In this case, theta equals alpha over 2. What is the meaning of the theta? Angle between R and F1. Resultant of the set of concurrent forces. If we have more forces, angle between them, theta 1, theta 2, theta 3, 2 theta n, are polar angle of the forces F1, F2, F3, Fn respect to. Then what is the R? R equals resultant square root x square plus y square. And direction tan theta equals what? Y over x. In this case, we find R and theta. Theta is inclination angle of R on OX, or inclination angle between R and F1. F1 represent OX, F2 represent OY. Dear student, in this case, we find the value of x as F1 cosine theta 1 plus F2 cosine theta 2 to Fn cosine theta n. After that, y equals F1 sine theta 1 plus F2 sine theta 2 plus 2 Fn sine theta n. After that, by substitution about R equals square root x square plus y square, we find the value or magnitude of the resultant of the two forces or coplanar forces. After that, when we find angle theta, tan theta equals y over x, we calculate or evaluate the value of y and the value of x. After that, we find tan theta equals y over x. Dear student, remark very important rules. If a set coplanar concurrent forces in an equilibrium, then x equals 0, y also equals 0. Now we are starting in fraction. Fraction, dear student, is very important. We have two types of forces friction. Friction, what is the meaning of the friction force? Friction force, there are two types of the friction force. The number one is called static force. What is the meaning of the static friction force? Static friction force appears before the body about to move. But the second type of the friction is called kinetic friction force. What is the meaning of kinetic friction force? Kinetic friction force appears when a body about to move. When a body about to move, the friction kinetic force appears, and the value or magnitude included between 0 and 1. In special body, friction force more than 1. The force of friction, it is hidden force, appears when trying to move a body on a rough plane. F resists the motion of the body, and its direction is opposite the direction in which the body moves or tends to move in it. Limiting friction force, we have two forces. When the magnitude of the friction force reaches its maximum value and which it cannot increase the body, then the power to move is called limiting friction force, FL. Dear student, we have two kinds of the friction force. Friction force, the first is called static friction force. Static friction force appears before the body about to move, but limiting friction force appears when the body, moves. Dear student, note that friction when two body or one body about to move, final friction is more than or equal, friction force. In this case, we have R dash equals R square plus F square. What is the meaning of R dash? R dash is called resultant reaction. We have two reaction force, normal and resultant. What is the normal? R square or N, normal. But R dash is called resultant reaction force. When a body, dear student, when a body put in the table, the body acts on the table by its weight. Every action has reaction equal in magnitude and opposite direction. Dear student, third Newton law say every action has reaction equal in magnitude, opposite in direction. Okay? If the body put in the table, the body acts on the table by its weight, and the table acts on the body by force. This force is called normal reaction. Normal reaction equal weight in smooth plane. But in the rough plane, we have resultant reaction. What is the meaning of the resultant friction? Resultant friction is square root of normal reaction power 2 plus F power 2 is called resultant friction force. In this case, we have very important equation. R dash, what is the meaning of R dash? Resultant reaction force equals square root normal reaction force plus F square. What is the meaning of S square? F square is limiting friction force. In case of limiting friction, we substitution about F equals mu. In this case, R resultant or R dash equal R square root 1 plus mu. Mu is called coefficient of the friction. Mu in this case, dear student, we have two coefficients of friction. The number one is called static friction coefficient. We can symbol MS. And kinetic coefficient friction, its symbol mu k. Dear student, this equation is very important. R dash equals R times square root 1 plus mu. What is the mu? Coefficient of friction. We have two types of coefficient friction. Number one, static coefficient friction. What is the meaning static coefficient friction? Static, what you mean? Before the body is about to move, static force is appears. Any static force has coefficient. Coefficient is called, yes, coefficient of the friction in static body. But when the body about to move or to move, the coefficient is called kinetic coefficient friction. Its symbol mu k. Represent coefficient of kinetic friction. In this case, R dash equals R. What is the R dash? Resultant force. What is the R? Normal reaction. We can represent by N. In this case, R dash equal R times square root 1 plus mu. Coefficient of the friction is called mu. We have two types of coefficient of friction, static and kinetic. What is the static? MS. What is the kinetic? MK. Mu K, mu S. Dear student, look at, in this case, mu equals force over R. When we find the force, we multiply coefficient times normal reaction. Look at, dear student, we have a body. This body put in a rough plane. Body its weight W. And normal reaction is R or N. We have two forces. The first force acts on the body. The second force is friction force, opposite and equal in magnitude. And R dash is resultant of normal and friction limit. Look at, dear student, mu in static or kinetic equals ratio between force and the normal reaction. Then we find, if we know mu or coefficient of the friction and the normal of the friction, we find the value of the force by multiply by mu times R. Then what is the rule of mu? When you find the mu or coefficient of the friction, we divided the force over reaction force. If we find friction force, we multiply coefficient of the friction is mu multiply reaction force is R. Remember, every action has reaction. Every action has reaction. Equal in magnitude and opposite direction. Look at R and W. R reaction, yes, normal reaction. W is force of weight of the body. R equal W. In magnitude, opposite direction. but when the force acts on the body appears friction force. This friction force is called limiting friction force. R dash resultant of the friction equals square root, yes, normal square plus F square. Mu is the ratio between magnitude of limiting friction and the magnitude of the normal reaction, R all N. What is the meaning of angle of friction? Lambda. The angle of friction between the resultant reaction R dash and normal reaction R. Remember, angle of friction is the angle between resultant reaction force R dash and the normal reaction force R or N, where the friction is limit. Tan lambda equals F over R. Remember, mu equal F over R. What you deduce? X and student. Tan lambda equals mu. When we find coefficient of friction, we find tan lambda or tan angle between, yes, normal and resultant reaction. Dear student, look at if we have two forces equal in magnitude and opposite direction in equilibrium. This is equilibrium of particle on horizontal rough plane. Look at body act. There are force FB inclined on x-axis by angle theta. We resolve in two axes, FB cosine theta and FB sine theta in x-axis and r-axis. The body, its weight W. Opposite it, reaction force is R. If the body, a force act on it, this force inclined the body by angle theta. We resolve this force by two forces. In horizontal, FB cosine theta. In vertical, FB sine theta. Find the two equations. Look at, dear student, the first example. Wooden block of weight 6 kg is placed on horizontal table and is connected by string passing over smooth pulley at the edge to a weight of magnitude 1.5 kg weight, which is hanging freely. Given that the block is in equilibrium, find the force of friction and the normal reaction. If the coefficient of the friction between the block and the table is third or 1/3, state whether or not the body is about to move. Look at the solution. Dear student, we have a body A. This body is weight 6 kg weight. This body is weight 6, opposite it reaction force. There is a pulley hanging in it by string B. Its body B, its weight 1.5 kg weight. Look at the two equations of equilibrium. The body B is in equilibrium under its weight 1.5 and the tension T1. What you deduce? T1 equals 1.5. Why? Because the body B is in equilibrium. We have two forces equal in magnitude and opposite direction. What is the two forces T1 and 1.5? Must be equal. T1 equals 1.5. Then T1, or tension of the first tension force, is equal 1.5. Look at the string passing over smooth Pauli. The tension doesn't change. What you mean? Look at T2 equals also T1. Each one equals 1.5 kilogram weight. Then T2 equals T1 equals 1.5 kilogram weight. The body A is in equilibrium. What to deduce? We have two equilibrium equations. What is the two equilibrium equations? T2 equals F. Remember, T2 equals T1. T1 equal 1.5. T2 1.5. Then F1 or F equals 1.5 kilogram. What to deduce? In this case, we have the second equation in an equilibrium force R equals what? W. What is the W? 6 kilogram weight. Then reaction force equals 6 kilogram weight. The limiting friction equals mu R. What is the mu? Equals third. What is the R? Equals 6. If we multiply third times 6 equals 2 kilogram. What to deduce? Remember, dear student, we compare between this force and 1.5 tension. Look at tension T2 equals 1.5, but this force equal mu R equal 2 kilogram weight. Then what to deduce? Yes, F smaller than mu R. What to deduce, dear student? The friction is not limiting and the body is not about to move. Why? Because F smaller than mu R. When F bigger than or equal mu R, the body in this case is about to move. But when we find the force is 2 kilogram weight, and the opposite direction is 2. 1.5 smaller than 2 must be F more than mu R. But in this case, F smaller than mu R, then the friction is not limiting and the body is not about to move. Dear student, by the end of the lesson, you know that static and kinetic coefficient friction. Dear student, remember, math simple, think, work, produce. Goodbye.